So we're working on 4.3. I went through steps for finding increasing and decreasing, and also from there you can get your maxes and mins. And now we want to go through an example or two examples. And first one. Okay, intervals where the function increases or decreases, and also find maxes and mins. The function is 3x to the fourth. Add 8x cubed. Subtract 18x squared and add 7. Okay, so we find critical points, and then we make a sign chart and split up the sign chart into intervals, and from there we'll get our increasing or decreasing. Use that info to find a max or min. Let's find the derivative. So we'd have 12x cubed add 24x squared minus 36x. Then we let f prime equal 0, or we figure out where f prime is undefined. Here's something like, if you have a number that would make the denominator 0, because you don't want to divide by 0, or any values under a square root that make that value negative, because you don't want imaginary numbers. But there aren't any square roots. We're not dividing by any x values. This is never going to be undefined. So we're going to go here and let f prime of x equal 0. Okay, so I'm going to leave this here, and it's set equal to 0. So this side, we can factor out x and factor what's left over and solve for those x values. This factors into, let's see, x plus 3 times x minus 1. Oh, I need to factor out, let's see, factored out 12. Okay, first. So sort of skipped a step, but we're just going to keep on going here with 12x times x plus 3 times x minus 1 equal to 0. So x is 0, negative 3, or positive 1. Cool. So those are the critical numbers, which we'll use to split up a sign chart. And the sign chart is for f prime. So really all you need is the number line. This is for your x values. This is just a label for the sign the sign of the function we're looking at. And it's going to give us intervals for increasing and decreasing. Oh, negative 3. And 0 and positive 1. So the first interval goes from negative infinity to negative 3. Negative 3 to 0. 0 to 1. 1 to infinity. So pick a number from that interval and test it in f prime of x. So I put in maybe negative 4. Maybe negative 1, 1/2. Okay, so I'm just going to use my scratch work. When I put in this as my test value into f prime of x, I got out a negative number. Okay, here I put in negative 1 and I got out some positive number. Between 0 and 1, I picked 1/2, and that gave me a negative number. And then I put in 2 to f prime of x, got out positive something, some positive number. Okay, positive goes with increasing, negative goes with decreasing. And then before we write out our answer, we're going to use this decreasing to increasing. And right here the derivative is 0. So we'll put a tangent line, it's flat, which is up right here, and decrease to increase gives a min. Okay, also right here the tangent line is flat. We go from increasing to decreasing. That would be a max. Okay, and at 1, also the tangent line is horizontal. Has a slope of 0. And we go from decreasing to increasing. So decrease and an increase. It's going to be a min. So increasing from -3 to 0 and 1 to infinity. Let's make it separate. Decreasing from -infinity to -3 and from 0 to 1. So I'm going to erase just the pictures, but we had a min and max. Okay. Okay, and then we're going to write the max and mins as points. So the max is the point 0, f of 0. Put mins at -3, f of -3, and then 1, f of 1. Okay, so make sure you put in that x value to the original function, back to f. So if you put 0 into f, you're going to get out 0, 5. Make sure I got that right. Actually, the function f goes blah, 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 plus 7, 0, 7. Okay, this one, -3. And the point goes to -290. And then we have 1, 0. All right, we're going to sketch the graph. Oh, by the way, this would be like relative max. That relative max was 0, 7. Relative mins at -3, -290, 1, 0. So let's plot these points first. 0, 7. Was a max. And -3, -290. We'll call it about here. And also at 1, 0. The function decreases till that minimum and then increases. We're going to bounce back through the min and increase onto infinity. Decreasing. Increasing. So decreasing from -infinity to -3. increases from -3 to 0. There. Decreases from 0 to 1, increase from 1 to infinity. Okay, so we're going to do another problem and then a little bit extra. Our function be 5 minus 3x squared add x cubed. Find intervals of increasing and decreasing. Also find maxes and mins. Okay, so we find the derivative and then check for critical numbers, make a sign chart, and pick out any maxes or mins after looking at increasing and decreasing. So we'd have -6x add 3x squared. And critical numbers. Okay, so this derivative, we don't have any roots to worry about. We're not dividing by any variables. This doesn't have any issue of having a value of x that makes the function undefined. So f prime of x is never undefined. Now let's do this part. Put this equal to 0. Zero equals -6x add 3x squared. So we're going to factor out -2x. Leave 3 minus 2x. Make sure I got that right. Nope, just a 2 minus 6. Where am I going? Oh, we factor out -3. There we go. That makes sense. Okay, so we're leaving behind +2. Add x, or subtract x, and there we go. So look at this piece, x equals 0. From what's in the parentheses, x would be +2. So from here, we can make a sign chart. And it's for the function f prime. So make sure if you test any x values, it goes into the derivative. Okay, so we're going to need 0 and 2. We test from negative infinity to 0. 0 to 2. 2 to infinity. Let's make sure you nice and clear. Let's put in something like negative 1. We have a negative times a negative 1, and this would be 2 plus 1, so this will give you a positive number. Let's put in 1. Negative 3 times 1 is negative 3. So negative 3 times 1 would be negative. And let's test out putting something like 3. Positive 3. Negative 3 times positive 3 is negative 9. If we have a 3 here, this would be a negative 1. So we'd have positive 9. So we're increasing, decreasing, increasing. Right here, the tangent line is flat, so we're going to draw a line, go from increasing to decreasing, like 0. Do also have a tangent line with slope 0. Oops, too much. And then you go from decreasing to increasing. So go down, and that's back. Okay, so that's a max. That would be a min. All right, so we're ready to answer the question. So we have intervals where we're increasing negative infinity to 0, 2 to infinity. Cool. 2 decreasing right here between 0 and 2. Okay, max is at 0, f of 0. So back to your original function. Min at 2, f of 2. Cool. Okay, so again, back to the beginning. You put in 0 and you get out 5. And if you put in 2, I got positive 1. And then I think we keep on working with this function. So first we'll draw a graph, and then we're going to do another sign chart. Okay. So let's plot these points first. And we'll make sure we meet these requirements. Yeah, we'll make it work. Okay, there's a max at 0, 5. Min at 2, 1. And then increasing until 0, until x equals 0. Decreasing between 0 and 2. That's actually, and then increasing again. So it's like bounce there and again and continue on. So when we go from decreasing to increasing, there's an inflection point right in the middle, right where that happens. So let's label that first. So IP for an inflection point. We're going to define that soon. I want to finish this example. So consider f double prime of x, and for our function, that's going to be -6 add 6x. And make a sign chart. So we're going to let f double prime of x equal 0. Equal to -6 add 6x. So we're going to add 6 over here, divide both sides by 6, and get x equal to 1. Okay. These are the signs for f double prime. And what we're doing here is finding places where the function is concave up or concave down. And again, I'm going to put those definitions soon. Just up or down. Practice. Okay, we had a second derivative critical point at x equals 1. And we're testing values into f double prime. So if I put in 0, I'd get out -6. If I put in 2, -6 plus 12 would be positive. So negative sign matches with down, concave down. And a positive sign is for concave up. So if you look at the function, we're concave down till right at this point here, 1 comma f of 1, which, like, let's see what. For me, it's at 1, 3. So I don't want my label to match. Okay, so I wrote that this is an inflection point. So we've got a good picture. Again, before we erase everything, this was concave down, right, till x equals 1. And we switch to concave up past x equals 1. For concavity, we're going to go over concave up, concave down, and inflection points. Concavity of a function. F is the shape of the graph and how it's increasing, or describes the shape of the graph, how it increases or decreases. Let's see. I guess increases. Oof. Okay, so first, for all of these definitions, we're going to have this introduction. Let f be differentiable on an interval I. So for concave up, just put this all in. Go with. Okay, f is concave up on I if the slopes of the tangent lines are increasing on I. Okay, so you need to make sure the slopes of the tangent lines, that whole piece, are increasing on I. Okay. So that would be when f double prime of x is greater than 0, you have concave up. So a few phrases that help me to picture it, and then we'll try to draw a picture. So it would hold water, or it would sit on the tangent lines. Okay, so I have the graph. So first we're drawing the function f, like something like this. And then we'll draw tangent lines. And let's write down slopes of tangent lines as we go. So the first one, let's say it's like right here. Tangent line goes down and over, so it's a negative slope. Let's call it like -3, just to guess. Next tangent line, let's go with a flat slope, slope of 0. I mean a flat line with slope 0. Next one, let's say that has a slope of 1, right there. Let's go kind of steep with a slope of something, we'll call it like slope 5. Okay, so we're going -3, 0, 1, 5. We're increasing with our slopes of tangent lines. And that's concave up. Let's do concave down. F is concave down. Let's see. F is concave down on I if the slopes of the tangent lines are decreasing on I. Okay, so we need those slopes of the tangent lines are decreasing on I. Okay, ways to remember this are it would spill water or it would hang from tangent lines. Okay, so we'll have a picture over here. We're going to have our function curve down. And then we'll talk about the slopes of the tangent lines. So let's say the first one's like, let's do a horizontal line at the top with slope 0. The next one has a slope that's going to go down and over, down and over. So I have like -2. And then another slope like over here, let's call that like -6. So 0 to -2 to -6, we're going to keep on decreasing. this graph is concave down. Last one is an inflection point. So, inflection points. Okay. An inflection point, which is a point x, y. Okay. It is a point on the graph of f where concavity switches. Okay, let's see. 5 minutes. I think we can hopefully, well, we can definitely do some sketches. Let's see if we can get to an example. We'll just do some sketches. Okay, first one. We're just going to talk about an inflection point. So let's graph y equals x cubed. You can come up and then flatten out and go back up. Okay, here to here is concave down. From there to there would be concave up. And we have an inflection point at x equals 0. Another one. So points where on the graph where the function's concavity switches from up to down or down to up. So we have an inflection point right where it switches from concave down to concave up. So I guess that it's like, say, here-ish. That's concave down until the inflection point, and then we go to concave up. So this function will have a peak. And then come up and down. And over. Okay, we have concave up. Continue to have concave up until that inflection point right about there, when you switch from up to down. Okay, from here to that vertical asymptote, we have concave down. And then this is concave down until an inflection point right about there. Okay, and then from the inflection point over is concave up. Okay, so when we come back next time, we want to go over steps for the sign chart where you're testing for concavity, and then do another example, and that's the end of 4.3. Okay, thank you for coming to today's class. Stop.